Can you see my presentation? Hello? Yep, awesome.
Yes, we can see.
Shall I start?
Yes.
Okay, cool. Good evening, everyone. My name is Trung Ngo. I'm the student of the online part-time machine learning course at CoderSchool. And today I'll be presenting about the human activity recognition project. So I would like to give you a quick overview of my project. By that, I really mean the two questions I'd like to answer for you. So the first is, what is the human activity recognition? Second is, how can we model it? And the third part, I will use a few videos that I prepared to demo the performance of the model. And lastly, time for the question. So before diving any deeper, let us first understand what is human activity recognition is. So to put it simply, this is the task of predicting the action being performed by someone. It is a very most important and challenging problems in the computer vision. It's a critical application in variety of tasks, including sport, health monitoring, robotics, and etc. So if you take a look at the backflip action done by this person in the video on the left, so you can only tell it is a backflip by watching the full video. If the model see only one images on the right-hand side, then this can look like the person is falling. So it's predicting falling. So human activity recognition is a type of a time series classification problem where you need the data in a series of time steps to correctly classify the action being performed. So in this project, I will train two models, which are the CNN and LSTM, and I will explain in further detail. Then during the demo, I will use a video that I downloaded from YouTube to test the performance of each of the model. And you will see how tricky for the machine to handle this type of problem. The dynamic in the image static and the background and stuff like that is all factored in the complexity of the model. So just a bit of the background. Here's the project timeline and how I spent the last couple of weeks on this project. So in my first weeks, I spent most of my time preparing the data set, brainstorming on how to tackle the problem efficiently. In my second week, I attempted to use the single frame CNN as the first start to model the problem. In my third week, I continued to develop the CNN LSTM model to see if there's any improvement. And the CNN and LSTM stand for long short-term memory. This architect is very also useful in the natural language processing and audio processing as children project as well. So during my first week, I used, so for the data set, I used the UCF 101 data set, but the original data set has 101 classes and it would take a long time to train. So I decided to modify it and only use about 8 subclasses as above. And every class contains roughly about 200 to 250 videos, each of 30 frames per second, roughly 3 seconds and 12 seconds per video. There's another factor that greatly influences the performance is the number of frames extracted per video. So after many trial and error, I tried to use about roughly 70 frames maximum per video for my training. And then during my second week, in my first attempt, I used the single frame CNN model. So on the left-hand side, you will see the model architecture. The right-hand side, the training accuracy and the loss graph. So this approach is similar to a normal image classification problem. But in this case, I ran an image classification problem to model on every single frame of the video and then average on the probability to get the final probability of the entire video. In my model, I run the average prediction on a certain number of frames that spread throughout the entire video to get a final prediction. And then in my third week, my next attempt is I upgrade that and I use the LSTM model with the feature extraction VGG16. So the idea in this approach is to use the pre-trained VGG16 to extract the local features of each of the frame on the input data, transforming it from the pixel input into an internal matrix, and the output of the VGG16 is then fed into the multi-layer LSTM network. In my model, the CNN is not trained. It acts more like an image interpretation for my LSTM model. I achieve very high accuracy on both training and validation set, roughly 92% on the validation and 97% on the training set. And it might be worth pointing out here is the input for the CNN LSTM, the 5D tensor compared to the CNN is a 4D tensor. And then in my final week, I spent most of my time improving the model performance by running the sensitivity analysis on multiple hyperparameters. And seeing the human activity recognition is a very challenging task due to problems such as background light, viewpoint, detail in the frames, appearance. So due to this problem, there's a drawback in the CNN model. The issue is that the model will not always fully confident about each of the video frame prediction, and the prediction will change rapidly and fluctuate. So here's the time for the demo, fun time. So I already prepared. So this is my Streamlit app, pretty simple. But what you expect from here is on the left-hand panel, there's two models in here, the CNN, the VGG16 LSTM. Of course, in the CNN, I got a number of frames here as a variable. So like I mentioned, you want to average on how many frames in that video. So I'm going to upload a video in here. Let's say I'll choose this one.
Very popular. The movement is simple, can be done everywhere, and it's very effective because you're using a lot of muscles at the same time.
Yep. So short video about push-up, and you can see the white background, the person is zoom in, the angle change. So on the right-hand side, you see the probability of my model come up with. So it's with one frame is very confident on the push-up one, but because this is a simple video, if you're increasing the number of frames over the video, then you start seeing the probability will change. So it will take a while for the model to tune it. So we start seeing the push-up reducing, the model confusing with the pull-up, and somehow applying makeup. So comparing the same performance, the same video for the VGG16 LSTM model, pretty fast, bang on. So when I change it, put it in, and then it's predict for me to push up right away. Right, so we start, let's see, like, something a bit more complex, army marching. So I'll cut this one out from the YouTube. So the entire video, you start seeing like the frame changing a lot in the video as well. A lot of people playing the factor in here. And then the VGG STM, again, pretty fast on prediction of this video. This video also longer than the previous one, 20 seconds. So it's come up with like roughly like nearly 100% marching, and the other two is very minimal, playing golf and lecturing. Why the CNN one? Again, if I increase that to 100, right? So it will take a while to run this one, but then it's not fully confident about the model. So it's got matching, pull up, blind makeup again. Yeah, so that's everything. That's all for my my demo. Let's go back to the presentation. So where's we go from here? I guess after this project, if I got more time, I'll probably comparing the performance between different sequence model. There's some other model that I'm fairly interested in, but then because of the time constraints, so I can't really try it out. Then I'll probably also train with a better GPU. I already upgrade to the Google Colab Pro, but then again, I still it's still crashing on my model when I try to train a lot of video. And then maybe apply some technique like noise filtering for the background to dampen that effect a bit. And definitely streamline the product for publishing. As you can see, I got a very simple Streamlit app right there. And then monitoring and continue to improve the model. And then, yeah, that's the end of my presentation. And I would like to take this time to thank CoderSchool for a wonderful course, and really enjoy it. And then make a lot of good friends along the way. Friendly TA, very caring instructor.